Steve here with SSI. Welcome to the show. Today I want to talk a little bit about my drill press. I've got an old Delta, I think it's a 40s model, drill press. Nice heavy cast iron base, table. I've got a cross slide table on it, little vise, so on and so forth. Now this drill press I've had for a long time, and it's been powered by just your standard 110 little electric motor there in the back. It works just fine. But all I have is on and off. So I always have to change the pulley speeds or whatever whenever I want to do some drilling. Now that's okay. It's been that way for a while. But what I would like to do, I'd like to change it to variable speed. You know, the only way I know how to do that is with a treadmill motor. Now, some of you that know me know what I've done to my lathe here is I've used a treadmill motor to power it. So I have variable speed. There's the controller in all its glory. And here's the hand controls. So I have a forward, reverse, and on and off in my speed control. So I can turn that on. Spindle's running, and what I've done is right there you can see the magnetic pickup on the spindle, because I have my tack right there. So now I have full control over spindle RPMs. Now the nice thing about this controller is I do have a forward and reverse, just like you would on any other lathe, and I can start and stop it at any speed that I want to with this on-off switch. Now what I've seen in the past on different shows I've watched about this type of thing, because I was interested in it and I had to learn how to do it myself, is that a lot of people always had the control board set up somewhere and they didn't mind it. It was a big bulky thing. They had to push buttons and always had to bring it up to speed that way. Well, that's something I did not want, so I had to figure out a way I could add that on-off switch so I could start at any speed, turn it on and off using just that. So that's what this show, or this new few segments here that I'm going to do, is going to be about, is how to wire up one of these controllers and make a pulley for it, for the motor, so you can run it on whatever application that you want to, and thus keeping the flywheel and original cooling fan that came with the motor itself. Now one thing I do stress is I bought these little fans at Amazon that help keep that control board cool. I don't know if it actually helps, but I always feel a little bit of warm air out of there whenever I'm taking heavy cuts or doing a lot of work with the lathe, so I know it gets a little warm. So there's two little 5-volt fans hooked into a transformer there that run whenever I kick everything on. That keeps that control board cool. Any kind of electronics you can keep cool, it's always better. So let's take a look. Alright, so here's the motor, what I'm going to be using. I put a little arrow on there so you can see the direction of rotation whenever it's running. It still has the serpentine belt system on it. I haven't done anything to this motor yet other than run it to test it. So all this is going to be included. So let's take a look at what we actually have here. So it's a permanent magnet DC motor, of course. Clockwise rotation. It's got an external fan. Electrical rating of 130 volt DC. 2 horsepower, treadmill duty, 5,950 RPM, 17 amps. So that's good. Everything that I put out here in the shop's all 20 amps, so that'll work pretty handy. So now you have all these wires that come out. So of course you have your standard black and red for positive and negative on your input for your motor. Then you have these 2 blue ones right here. Now these 2 blue wires go to the back of this motor, and inside the motor itself is a thermal control. So on the AC side of things, your black wire runs in one side, out the other. Now, judging by what you do whenever you pull your treadmill apart, just make sure you know which wire goes where and which is your input and which is your output for your thermal control. It's something that I put on all of these whenever I do them. I still use them that way. So on the milling machine is the same thing, and I do a thermal control with it, and it's built the same way. Got the little motor, pulley, tack, the whole deal. So they come in pretty handy. I've done this a couple of times, so I'm getting kind of used to it. Now on the other side of things, we have this. This is the actual controller itself. And this is an MC60 treadmill control, and that's the choke for it. So the choke's usually on the negative side of everything. It's not a transformer, it's a choke, so it helps with electrical noise coming from the transformer out to the motor. Plus, we have our switches, our potentiometer, and the whole kit and caboodle here. Now, getting more involved in this, this is a double pole, double throw switch. So it's on here and on here. This is the wiring for it, of course, on the back side, and we'll get into that here in just a minute. This is the off and on switch. Same kind of deal, just a couple of little wires, no big deal. So let me get this flipped over and we'll talk a little bit more about it. So here we are at the controller. Now you'll see a lot of cases where it helps everything if it's all labeled for you, so that's a real help. So this is our AC side in. So you have the white wire and you have the black wire. Now there's a ground that runs on the equipment itself. Do not hook the ground directly to this controller. First thing it'll happen, it'll blow the circuits right out of it. I've done it one time, so I'm not going to make that mistake again. So hot side in is the blue side, which is what you will go in and out of the motor and back to the control board for your input. White side is your neutral. Got a wire nut there, but it actually listed as white. And then you have your DC voltage on your output side. So you have a red and a black. Now I've got a white wire tied to my red side, but I know what color it's supposed to be. So that's your output for your DC side. Now over here is your potentiometer. So you have a black, a white, and a red. The red wire is where the off and on switch goes. You break it to break the circuit. So that's the biggest help right here. This kicks it on and off, whatever speed you're in, it'll turn it off, turn it right back on, it automatically goes to the same speed you were just at. So the red wire is the key. The white is your wiper, and I guess the black is the black wire, high tension, whatever it is. But those are the three that it reads. Now the potentiometer I have on this I'm going to read on it here, is an Alpha A 5K potentiometer. Now a lot of these I have used 10K and 5K. Both of them seem to do about the same amount of work, about the same job. I think the 5K is a little bit more sensitive, but that's what I've got on this one for the drill press. Now on the AC or the DC side coming out, that's where I've got that double pole, double throw switch, right? So looking at the back of this, that white out and black out, or your red and your black for your DC side out, go to these middle components, middle prongs right here. So that's the power in for the switch. Then the power out for the switch is there also another black and another white that comes out of this side right here, off these two poles. So this pole and this pole. So how do you get the reverse? Well, that's pretty simple. On the other side of this switch, you'll see two green wires. You can see how they're crossed. Those two green go to the output to the motor, to these two, this black and this white one here, on the output side of things. So those two go in, then they blend in with this black and white wire, then go out to the motor. So what you do whenever you flip the switch one way or the other is you actually flip the polarity. So DC positive negative in, you have normal DC positive negative out on this side of the switch. When you flip it over to the other side of the switch, to the reverse position, then these two wires activate and they're swapped. So now your positive is your negative and your negative is your positive. Still go to the black and white wire out to the motor. So that's the whole trick of that. That's not that big a deal. Just make sure whenever you buy one of these switches that it works the exact same way. It's double pole, double throw. So let's hook everything up and give it a test. See how it works. Okay, I've got everything plugged up. You can see the board is energized. There's the little red light right there. So the board's on, everything's hot. Now one thing I didn't cover a second ago was the choke, how it's wired into this system. So there's the choke right there. Now what I've done with it, it's always on the negative side of things, so it's actually hooked in to the negative side of this board on the DC output side. So it goes out to the choke, then from the choke it goes out to the input of the double pole double throw switch. So I'm going to turn. You don't want to touch any of these bare wires sticking out, they will knock you down. So I'm just picking a direction. Don't know what direction it is, but I'm on one side of that switch. Okay? And I'm going to come over here and I'm going to turn this to the on position. And there's my potentiometer. You definitely don't want to grab the wrong wire on this little dude. It's pretty, it'll bite you. So let's see which way we go here. So we're going toward me, the way the arrow's running. So there it is right there. So the potentiometer, very low. There's my off switch. So I'll give it a little bit of speed. You can hear that little bit of whine to it. I think it's mainly because it's going in the wrong direction. It is, it's going back, it's going counterclockwise right now. It's in reverse. So that's okay. We can change that. So if I want to turn it off, I just flick that switch and it turns off. And if I want to bring it back at the same speed that it was just at, I don't change anything on the potentiometer. I just turn the switch back on. It'll pick it up right back in the same place. So that's the beauty of that. I love that little part. So what I'm going to do is I'm going to turn it off. Then down here on my reversing switch, I'm going to go the other direction. So that should be forward, clockwise rotation. Haven't changed anything on the potentiometer. Just going to flip this switch and it picks up the other direction. And now you notice that the little whine's gone. And it'll run all day just like that. And what's nice about the treadmill motors is it's got the torque control. So if something tries to bind it, it speeds up automatically, pours more power into it. So there's a pretty good rate of speed right there for it. We'll slow it down just a little bit, and when it gets to that RPM that I've slowed it down to, it'll pick it right back up where it was. And there it is. So this is what's going to go on the drill press for a variable speed motor. So the thing that I'll do probably next is I'll take this billet of aluminum right here and make a pulley for this motor, V-belt pulley, so I can use it on my drill press. So these are left-handed, and whenever they screw off, it'll go off the opposite direction, the normal nuts do. And I'll show you how to pin this cast iron piece onto this shaft so it doesn't spin off on you for reversing applications. And what we'll do is we'll turn these serpentine grooves off, and the whole trick about this is just to turn them off enough where they just disappear. You don't want to go any smaller than you have to. Then we'll bore the aluminum piece, put it on here, put a set screw in it. We'll actually make the pulley while it's on this cast iron piece in the lathe. That way everything's straight and true, and we'll talk about belt sizing and pulley widths and all that kind of stuff when we get there. But for right now, that's where we're at. That whole mess of wires just for that little operation. And whenever we get into it later, actually putting it on the drill press, all this stuff will be cleaned up and prettied up and zip tied into place and actually made to the proper lengths. So, but for testing and to show you how it kind of goes together and what you can do, that's where we're at so far. Now, there is an instance where one of these controllers actually has a pulse control on it. I've only ran across it one time. A friend of mine bought one that had a pulse control, and it's a pretty simple little system to bypass as far as getting ready the control system. He bought a pulse controller off of Amazon, I believe, for like 20 bucks, and he gave me a wiring diagram of how to actually put it together and wire it into the system, and oh my goodness, it is nice. So one of these days when I run across one of those, we'll go over this again, maybe in a little bit more detail, and show you how to put a pulse controller on one of these systems. So I appreciate you guys watching. All my subscribers, thank you guys very much. Always, if you're new to the show, like me, subscribe. Go to my Facebook page. I've got lots of little projects on there that I've done over time that you might want to see. Thank you very much.